And we are back, and we are about to get into our next problem, which is doing some hypothesis testing with some data acquisition devices where we don't have the data per se. So let's go ahead. I'm going to exactly shrink this one down. And we are going to use our functions up here to answer some of these questions. So I'm, excuse me. I'm going to define, actually, I'm just going to go step by step. So we're given some values here about the product. So we're asked, does product 3 come from a population with a mean of 14.8 at a 1% significance? So we have to do T experimental. Actually, let's set up our hypothesis testing here. So for example, for A, our H naught is going to be mu is equal to, or mu naught is equal to 14.8. Our alternative is it's not 14.8. So our 1, 2, 3, our confidence interval is 99%. So our alpha is equal to 0.01, but our alpha over 2 is equal to 0.005. 4 is going to be our T experimental, which we're going to calculate with our program. And then finally, we have our T 0.005, alpha over 2, 0.005. And then our degrees of freedom, because we have, this is product 3, average voltage, and we have 6 samples. So it's going to be 5, and we're going to look that value up. So let's go ahead and get at it. Oops, not that. We need, so I'm going to do T experimental. So we need our X bar, which is going to be for product 3 is going to be 14.8. Our mu is 14.8 as well, so it's going to be 0, but let's just work this out. 0.5, and then finally our N is going to be 6. So we can find that T experimental, 0. And now we can look at our T005. Let's go ahead. T005 for 5, which is going to be 4.032. So let's go back. 4.032. This is 0. So we know if we're looking at our two-tailed test, that is going to be a big old do not reject. Excellent. So let's go ahead and we're going to erase certain things here. And we're going to look at the next one. Product 2, so mean less than 14. So we know that our TA has to be a negative here. Excuse me. So even on the do not reject, so for A, we know then our p-value has to be greater than 0.005. So that would be our result there. So that is our bounds effectively. Product 2. So we're going to assume 95% because we're not given anything. This is not, so our alpha is equal to 0.05. 0.05. Our nu, because it's product 2, is going to be infinity. And it needs to be negative because we're a left-tailed test, less than. So 0.05, infinity, 1.645. Minus 1.645, because again, we're now left-tailed. So it's basically looking at something like this. Our T experimental, let's find it. T experimental now, let's just copy and paste this. So we are product 2. So our product 2 says an average of 13.2, a mu of 14, and then product 2, 13.2, standard deviation of 2.1, and then, what is it, 54? So minus 2.799. So this is a reject. So our p-value has to be less than 0.05. All right. And then finally, does product 1, let's erase. Does product 1 come from a population mean greater than, and this should be significance, sig, greater than 14. So greater than 14 at the 95% confidence, so our alpha is equal to 0.05 again, except this time our nu is going to be, because this is product 1, product 1 is 13.7. Excuse me, no, 13.7. It's going to be a new 16. So if it's greater, we know it's going to be positive. 05, 16. 05, 16, 1.746. 746. And our T experimental, let's go ahead and calculate that out. So let's do T experimental times, let's see, we're looking at product 1, 13.7, 14, standard deviation 3.7, 17. So that's going to be minus 0.33. So that's a big old do not reject because we're a right tail test, and we know that p-value is going to be larger than this value here. Fantastic. Done, done, done. Now we're asking, are 1 and 3 different? So let's go ahead and let's look at this here. So now we need to look at so we need to use our t-test comp. So we're looking at 1 and 3. So actually I can kind of look up here. So 1 gave me, oh shoot, this is not in order. I can arrange this in order though. So we're looking at, actually it's just reverse order. Perfect. So are 1 and 3 different? So 13.7, 14.8, those are my means. Then I need my standard deviations, which is going to be 3.7, 0.5, 3, 2, 1. And then it's going to be the number 17 and 6. That's my t-test value. I need my new, so this is new comp, but I need to get rid of those values initially. So my degrees of freedom are, let's just say it's 18. So in this test, for example, so I'm looking at 10% significance, but this is going to be an alpha equal to 0.1, but it's divided by 2, so alpha equals 0.05. And our t of 0.05 plus or minus, and our new is going to be, let's just say 18, so 0.05, 18, 1.734 plus or minus, because it's a two-tail test, because we're looking at those differences there. And we can see that our T experimental was minus 1.19, so we are in the do not reject. So we are do not reject regime, so our P value has to be greater than this. All right. Now we're asked about, is 3 greater than 2? So here our alpha is equal to 0.01. It's not divided by 2 because it's a greater. So let's go ahead and let's run this one through. So is 3 greater than 2? So we need to basically pull this out. So instead of 1, we're going to put in the 3, so 14.8. Instead of the 3.7, actually it's 3, we need the order to matter here. So let's just do this. Let's just do this nice and comprehensively. So is 3, because we did, one second. No, 1 and 3. Okay. All right, so t-test comp. So is 3, which is that 14.8. 1 is 1 and 2, 13.2. Our standard deviation for 3, excuse me. I'm just off on that one. And then 2 is 2.1. Then our number of 3 is going to be 17. Oh no, excuse me. I'm just so off. It's been a long day. 13.2 for 1. The standard deviation is 0.5. Then it's 2.1, and then the number of 3 is going to be 6, and then 54. All right. Whew. A little difficult there. All right, so that's our t-test composition, or t-test comparison value, so 4. And again, this is a greater, so we can copy this same thing, and then let's put this into new comp, and then let's delete these characters. 0.5, 2.1. So our new is basically infinity. So we're looking at a t of 0.01 infinity. So let's pull that up. T of 0.01 infinity is 2.326. That's 2.326. So if I look at this, we are definitely in the reject. So we know our p-value is going to be less than this alpha right here. And then finally, is 2 less than 1 at a 95%. So our alpha is equal to 0.05. So our t is 0.05. We have to figure out the new. And remember, it has to be a negative value because we're left-tailed. We're less than on this one. So let's go ahead and knock this out. So we're going to do t test comp. And it's going to be is 2, 13.2, 13.7. Then we need 2.1, 3.7, and then finally 54.17. We got that value for our t-test comparison. We're at the home stretch. New comp, and then finally we've got the values here. 19, so let's go ahead and put that there. 19, so 0.05. 0.05 and 19 is going to get us 1.729 minus 1.729, and we are negative here, so we are in the do not reject, and then that means our p-value is greater than this alpha right here. There it is. So see you all in the next video. Thanks. Bye.